get like a sheet here for you to actually see each specific reference for each topic right there. So for example, this is why you need to watch the introduction. If you need to study on temperature, you could go to adverse recircular 006 and just study temperature on that specific adverse recircular. This makes it a lot easy to get to those references, as with the entire concept with the pilot ground briefs course. So I really hope this helps. So if you need like the full ACS, we'll be providing a downloadable version for all the topics we cover in the pilot ground brief. So make sure you get that copy so you can study most of these references on your free time. Again, most of the idea in this course is just giving you most of the highlight of the information. So it's also up to you to go in and just study it a little bit deeper to make sure you grasp the concept of the what the topic is trying to let you understand. So without taking up too much time, I'll go into the main things we'll be covering for today. So we'll start with knowledge area 1, which talks about sources of weather data and acceptable weather products. So if you really need to study sources of weather data, the reference here is AIM 7-1-2. so the AIM is the second part of the FAR AIM, the big fat book of regulations. So everything in the AIM is more of like a recommendation than a regulation. So it's the Aeronautical Information Manual. That's what it stands for. So a lot of the things we'll be covering here really touches upon the AIM. So the sources of weather data here are the main ones you really need to be aware of is the National Weather Service Center. You can get that at www.weather.gov. Then you have flight service stations. So the flight service stations for us pilots, those are basically our primary sources of pre-flight weather information. You can usually call them on the phone. The phone number is 1-800-WX-BRIEF, or you could go to their website at 1-800-WX-BRIEF.com to gather most of your pre-flight weather information. So there's stations all over the country where they have staff where they can answer your calls and actually provide you with a full briefing of what you need. So in general, you basically have like 3 types of briefing you can get. I didn't put that in the slide here, but just to let you know, you can get like an outlook briefing, which is if you're flying days ahead, you could get an outlook briefing. Or if you call them, you can tell them you need a standard weather briefing. So the standard weather briefing is what you typically get if you don't know what the weather looks like, and that typically takes like a long time for them to actually give you all that information. So you may be on the phone for about 30-45 minutes talking to them. But if you really want to get like a quick understanding of what the weather looks like, you can just get an abbreviated briefing. So those are the 3 types of briefing you could get from the flight service stations. So your outlook briefing, your standard briefing, and the abbreviated briefing. And then you have your flight information services. So this is the FAA. So this is typically through the ADS-B in the system in your aircraft that shows you weather information. So this you just need to know sometimes in those advanced aircraft that has like weather information, they use the FAA system through the ADS-B in on the aircraft. So they're typically a little bit delayed sometimes. So you need to take the weather information with a little bit grain of salt. The Pilot Ground Briefs program is a program that's there to help aviation enthusiasts or student pilots sharpen up their knowledge. But I just know if you do purchase this course, you're helping somebody out there successfully become a pilot. So with that being said, I'll just show you how you can get access to the course. And I'll come in here. If you do come here to this page on this link here, we currently have it on the Teachable platforms. But if you do come to the page here right now, you can scroll down to where it says to choose a pricing option. And we currently have the course going for $199. So like I said before, if you do purchase, just know you're helping somebody else become a pilot, and you'll also be getting access to great content that's going to help you sharpen your aviation knowledge. So I look forward to seeing you in the course if you do purchase. And in the meantime, we'll go back and focus on the content for today. The other acceptable weather products that you need to be aware of is if you already started training, your instructor probably already told you about ForeFlight or Garmin Pilot app. So these 2 are like apps that are electronic flight bags, EFBs. So they're considered EFBs. So these are apps that have like detailed map, sectional charts, things like that. And they also carry a lot of weather information. So if you're using any of these apps, just know that they're acceptable. You can actually use them for your pre-flight planning and things like that. So it's going to be a very, very useful resource for you while you go through your training. Personally, and this is not like an ad or anything, but I like to use ForeFlight, and I've used Garmin Pilot app too. So I use these two apps, every now and then just to make sure I have like a easy access to weather information. And they do require a paid subscription. So, I believe some of them offer like free trials. So, if you want to try the free version for each one and then see which one you like. And then there's many more apps out there you can actually use as well. So these are very useful and acceptable weather products and resources you can use. Then we'll move on. We'll talk about types of weather information here. So to read a little bit more about the different types of weather information, you can read Advisory Circular 00-45. Just make sure they usually have letters at the end. Just make sure you're reading the most up-to-date version for whatever information you need to get, or if you're watching this in the future. So the example of like the weather information you could get, the first I'll talk about is the 𝒂𝒄. So the 𝒂𝒄 is the terminal area forecast. So this typically just provides a forecast of weather conditions around the airport, and it's typically issued 4 times a day and it's valid for 6 hours. So you can basically think about 24-hour block. For every 6 hours out of a 24 hours, they issue a new updated weather report. And then the METAR is basically your meteorological aerodrome report. So METAR basically just gives you local weather around the airport, the local vicinity of the airport. So this is typically reported every hour. The next one is the 𝒂𝒐. So the 𝒂𝒐s are issued typically for like less severe but potentially hazardous weather conditions. For example, if you have moderate icing or moderate turbulence, they issue 𝒂𝒐s for these things. So these are basically conditions that affect small aircraft. So an 𝒂𝒐 would typically not affect like a big aircraft. And then continuing about more types of weather information, we have 𝒂𝒐. So the 𝒂𝒐s are severe sort of like weather reports. So they basically provide information about weather that could, affect the safety of all types of aircraft. So you basically have 2 types of 𝒂𝒐s. You have the convective 𝒂𝒐s and the non-convective 𒂂𝒐s. So the convective 𒂂𝒂𝒐s basically just warn us of storm activity like thunderstorms, heavy rain that has like tornadoes, like hail that's greater of at least 3/4 of an inch, and wind shear. So these are convective 𒂂𝒂𝒐s. These are like severe weather phenomena that has to do with convective activity like thunderstorms and things like that. And then the non-convective 𒂂𝒂𝒐s, so those are just basically like more severe versions of 𝒂𝒐s. So these are like severe turbulence, severe icing, sandstorms or dust storms that are reducing visibility to less than 3 statute miles, and volcanic ash. So anything that basically just affects your visibility, and severe versions of 𝒂𝒐s that can actually affect bigger aircraft. Those are non-convective 𒂂𝒂𝒐s, and obviously and non-convective because they don't have convective activity like thunderstorms. So that's the difference between convective and non-convective. And then another type of report you can get is a PIREP. So the PIREP is actually short for pilot report. Basically just this is most likely one of the most reliable sources of weather you can get, the PIREP, because this is an actual report from a pilot that's out there in the sky flying. So it's just telling you, okay, this is what the weather is like up here. So this is why we consider them the most reliable sources of weather. And then moving on, we basically just covered knowledge area 1 and 2, and then knowledge area 3, the main reference for most of the items that will be covered in this section. You can find that on AC00-6, which is the advisory circular for aviation weather. This has a lot of information about weather. Please make sure you read that. Basically focuses on meteorology. So this is where most of the theoretical thing that students struggle with during studying. This is where most of this is where most of that content comes from. So I'll try my best to make sure I explain in a way where we make things a little bit easy. So on this slide here, we basically have like atmospheric circulation, which is basically just a general depiction of how the atmosphere is formed. So atmospheric circulation is basically the movement of air relative to the Earth's surface. So this kind of like forms the basis of like how weather is formed. So every physical process of weather is accompanied by or is a result of a heat exchange. So the sun is very, very important. And the unequal heating of the Earth's surface modifies air density and it creates circulation patterns. and causes altimeter settings to vary. So this is a combination of different things now, because the earth rotates, and you also have heat. So these are things that cause this different weather phenomena to occur, and primarily the heat exchange. Then we'll move on. We'll talk about atmospheric pressure. So in this picture here, kind of like gives you a general idea, which in a few slides to come, I'll be talking about this specific picture here, or this chart here. Just I want you to hold the image of this chart in your head, because this is going to be very, very important throughout your aviation career. It's important to be able to tell what everything on this chart means. So we'll be going through everything in detail, but I'll start covering some of the ideas here. So the thin lines you see here, the thin gray lines you see here, they are called isobars. So these are lines that are connecting areas of equal pressure. And then you also have a pressure gradient. So pressure gradient is basically how these thin lines, how close they are together. For example, in this area where you see they're not too spaced out compared to this area. So it means here your pressure gradient here is really high, and your pressure gradient here is low. So your pressure gradient basically tells you the speed of wind. So whenever you have a high pressure gradient, the wind in that area is going to be a lot higher. Wherever you have like a low pressure gradient, which is typically in areas where the lines, the isobars are more spaced out, you have, slower wind speeds. So that's the idea with the isobars. So we'll take a deeper look in a future slide with most of the details on the chart. So wind. So how is wind formed? So this here will basically help us understand how wind is formed. And it's basically a combination of the Coriolis force and the inertia of the rotating earth. So because the air is constantly rotating, so basically it creates a Coriolis force. So Coriolis force is basically the force that affects the movement of air that's in the atmosphere. So basically, because the air is constantly rotating, the air in the atmosphere, or the earth, is constantly rotating. So the air in the atmosphere is not just going to move in a straight path. So the force that causes the air to move in different directions is called the Coriolis force. And this force basically allows air to rotate to the right in the northern hemisphere, and it allows air to deflect to the left in the southern hemisphere. So that's the idea with the Coriolis force. So this is basically the force that influences the movement of air. So that's the idea. So it's the combination of the Coriolis force and the pressure gradient is what creates wind. As you can see from this picture here, it gives us like a gradual idea of how this is formed. So remember, in the previous slide, we talked about how the pressure gradient is how the isobars are spaced. So really tight isobars, that's like a steep or a high pressure gradient, which means the wind speed is going to be a lot higher. And if it's more spaced out, the wind speed is going to be a lot lower. So looking at how the wind moves along isobars. So like we said earlier, the isobars are lines connecting points of equal pressure. So I'll just come back here to this slide just to show you a few things. As you can see, these numbers here kind of like show you the pressure. So this number I'll take here, for example, is 1024. So it represents the pressure that this line represents. So if you go across this line, every point that this line connects is about 1024 in terms of the pressure. So that's the idea. So the isobars are basically just connecting points of equal pressure. And then we have different types of pressure systems, which is represented by the H, as you see here, and the L. So the L is a low pressure system, which is typically depicted with a red color. And then the H is basically a high pressure system, which is depicted by a blue H letter, typically on the chart. So it's important for you to understand how the pressure systems affect the movement of air. So I came up with an acronym here, to help you memorize the movement. So low pressure system, basically in a low pressure system, air moves ICU. So it moves inwards counterclockwise and it moves upwards. And then in a high pressure system, air moves OCD. So O for outwards, C for clockwise, and basically air is going down, and it moves clockwise and outwards. So it spreads out. So we typically associate bad weather with low pressure systems, and we associate good weather with high pressure systems, and you'll see why shortly.